Hello everybody, in this lecture we will be solving 1990 IMO problem number 5. Here is a view of this problem. We're given an initial integer n sub 0 greater than 1 and two players play the following game. They alternately choose integers n1, n2, n3 with odd numbered indexes belonging to A and even numbered indexes belonging to B. So they alternately play this game and A moves first. So knowing the previous number, A can choose any number between that given number and its square. So A can choose any number in that range, versus B can choose any number n sub 2k plus 2, knowing the previous number, such that it will make this fraction a power of a prime, a positive integer power of a prime. So therefore this would imply that B can choose a number of this format, 2k plus 2. So that's what B can choose. And finally, player A wins this game by eventually choosing the number 1990, versus B can win this game if B can eventually choose the number 1. Whoever chooses their respective numbers first win the game. So first we need to establish whether A have a winning strategy. Obviously the winning strategy will depend on the initial choice, initial integer, and then in part B we will try to figure out under what conditions B can win, and finally if there is a situation where neither player wins the game. So as I said, this is a typical game theory problem. Let's start the investigation. So first of all, let's focus on this number 1990. So 1990 is between 45 square and 44 square. I believe 44 square is 1936 and 45 square is 2025. So therefore we can look at different ranges. So let's start with let's investigate part A first. So let's try to see if we can find winning strategies for player A. If n0 is given in the range 45 to 1990, then obviously, for instance, if n0 is 45, n1 can be, player A can choose anything between 45 and 45 square, which is definitely including 1990. So therefore in this case, so that's the first condition here, A picks n1 equals 1990 directly. He can do that and wins this game, and A wins. End of story. Okay, so next consider the situation where n0 is between 27 and 44, and I'm saying 27 after some trials and errors, obviously. So but it turns out 27, and so in that case A simply picks, that's strange, A picks n1 equals 720, which is 2 to the 4th power times 3 squared times 5. In that case, so once A picks this number 720, then B picks, so B has multiple options. So the smallest that B can pick will be, using this situation, 720 over the small, so I can get the highest power item is this one, so 2 to the power 4. So eventually, so therefore the smallest that it can take will be 45, and the largest that it can pick is, the smallest among these numbers is just 2 itself, so 360. So therefore the choices of B will be, so n2 will be between 45 and 360. But when that happens, we're back into, so now we are in the second case, obviously we're back into this case, right? Because we restricted n2 to between 45 and 360. We are back in the first case. In that case, A will simply pick, A picks n3 equals 1990 directly, and A wins. So therefore, even in this case, A can win easily in just 2 steps, unlike the first situation where A wins in just 1 step. Okay, so next, what happens if the initial number is between 15 and N026? When that happens, A picks, it turns out A can pick the number N1 equals 210, which is obviously equal to 2 times 3 times 5 times 7. 630, yeah, 210. And in that case, B picks, again using the similar analogy, the smallest that it can pick is so 210 over 7, right? So that would be 30, yes. And the largest that it will be able to pick would be 210 over 2, which is 105. So therefore, sorry for that. So therefore, N2 will be between 30 and 105. But then when you compare it with the previous 2 intervals, so if it is anywhere between, so if N2 is between 30 and 44, in that case, A will continue to pick 720, right? So therefore, A picks 720 if N2 is equal to, well, if N2 is between 30 and 44, and it directly picks 1990, so it directly picks 1990 if N2 is greater than 44, right? Well, obviously greater than 45, sorry, and less than or equal to 105. When the first situation happens, let me write it like this: A picks N3 equals this. So the game will automatically end if that's the case. In this party, in the first occasion though, the game will be played again, but because the case reduces to this situation, regardless of the choice of N4, N5 will eventually force a win. So therefore, and A wins definitely. Either A wins after N3 or A wins after N5, basically. So A will win in this interval again. Now that we understand the logic, we can get faster probably. So 11, N0, 14. When N0 is given in this range, A picks N1 equals 105, which is simply equal to 3 times 5 times 7. Then B picks 105 over, well, the smallest. So B picks smallest. The smallest it can pick is 105 over 7. 105 over 7, which is just the product of the two, 15. And the largest it can pick would be 105 over 3, which is 35, suggesting, so therefore N2 will be in the range of 15 to 35. So going back to the previous case, so anytime it ends up between, so we have again a sub case. So A picks N3 equals, so A will pick N3 equals 210 if N2 happens to be between 15 and 26. If N2 is between 15 and 26, and it will directly pick 720 if N2 is between 27 and 35. If this case happens, the 210 case happens, then in the next round, A will pick N5 equals to, well, it will follow in the following order, right? Depending on what N4 is, 720 or 1990 directly. And so you can think of this like a tree diagram, right? So, and once you pick, if it is the case that we pick 720, then N7 eventually will become 1990. So if it is 720, then we can finish it earlier. N5 would be, I think N5 directly becomes, yeah, N5 will definitely be 1990. Okay, so A wins again, and A wins. Yes. Okay, next round. Well, next interval. So between 8 and 0 and 10. A picks, so in this range, A will pick N1 equals to 60, which is 2 squared times 3 times 5. Then B picks, the smallest that B can pick will be 60 over 4 is less than 5, so we need to pick 5, 12. And the largest would be 60 over just the 2, right? So it would be 30. So as a result, therefore, N2 would be between 12 and 30. Therefore, again, so if N2 is between 11 and 2, so if, sorry for that, if N2 is between 12 and 14, so A picks N3 equals, so N3 equals 105 if N2 is between 12 and 14, and we will directly pick if N2 is between 15 all the way to 30, right? So 15 to 26, I should rather say 15 to 26. Then we will pick 15 to 26. Yeah, we will pick 210, or if between N2 is between 27 and 30, then we can directly go to this case and we can pick 720. But regardless, so in the next step, in this situation, N5, we will win in the next step. In this one, it depends. We can win in either one step. In N5 we can get 1990, or we can win in the next step, right? So because when it is 210, as you see here, it might take several steps. Or we can win in N7. And the same thing here. So it is, but regardless, A wins again. A wins. Okay, so unfortunately, this will fail. This procedure will not work for smaller numbers. So therefore, now let's focus our attention on what if N0 is strictly greater than 1990. So the choices of A are such that our numbers will become bigger and bigger, versus the choices of B that B makes our numbers smaller and smaller, right? So therefore, we can, well, I should say, so A will receive a number, so if that's the case, let's say that eventually A receives a number N sub 2k from B, right? So we receive this number, and now A can do the following, a very smart strategy, and A can pick a number in the following range, 2 and 2 sub k, in the following range of the form so n2k plus 1 will simply be equal to 9 times 2 to the power j. I claim that there will exist a number like this in this interval, and that makes perfect sense because eventually this gap has a multiple of 2, so you cannot jump. So the 9 times 2 to the power j, like the previous 9 times 2 to the power j minus 1 being here, and then 9 times 2 to the power j will be here, it won't happen, right? So you can't make a jump, so one of them will fall into this interval. So you just pick this number, so A will pick that number, and when it is B's turn, so A picks this number. So when it's B's turn, B picks so the smallest and the largest, right? So the smallest that B can pick would be 9 times 2 to the power j over 2 to the power j, which is 9. And the largest it can pick would be 9 times 2 to the power j over 2, which is 9 times 2 to the power j minus 1. So what we did is we effectively forced B to pick a smaller number, and yet it's not smaller than 8. That's perfect. So we forced B to pick a number smaller. In the case that this number here is still bigger than 1990, no worries. A will pick, so therefore n2k plus 2 will be such that it will be a number in this range, 2j minus 1. If it happens that this number is still greater than 1990, A again will use the similar strategy. We will find the number in that range. So whatever number the n has chosen to, so if, well, so we have the following case. A picks, well, it can eventually lead to pick 1990, right? So if n2k plus 2 is less than or equal to 1990, not a big deal. Maybe not in one step, but eventually it will pick that number, right? So n picks in n2k plus 3 or later on. But if it happens that n2k plus 2 is still greater than 1990, we can go back to this procedure. We can find 2 times this number and find the interval between 2k plus 2 and 2 times n2k plus 2. This is open interval here. Pick the number which will be of the form 9 times 2 to the power, let's call it, I don't know, L, and then do the thing again, right? So eventually we are forcing B to choose smaller and smaller numbers, because and once it falls under 1990, luckily it will not be lower than 9, and A under this strategy eventually wins, and A wins again. So that was a very important observation. So for any initial value more than 1990, A will definitely win. Okay, so how about so far we have covered a lot of cases. So the remaining cases are what happens if n0 is between, well, if n0 is between 2 and 7. Well, it turns out that if n0, so if n0 is between 2 and 5, let's first investigate this case. Then A picks, well, A will definitely pick a number n1 less than or equal to 25, right? So because we cannot go more than the square, obviously A will not pick 25. In that case, B picks, if for instance A picks 25, B will just pick something and divide it by 20, so it will directly pick 1. So if A picks 24, for instance, 24 is 2 to the 2 cubed times 3, so B can divide it by 2 cubed. So it will further reduce the number, right, to 3. So it will restrict in the next step n1 to be less than or equal to 9, and so on. So it will, or if obviously A cannot pick 23, if it picks 23 in n1, B will just divide it directly by 23, which is the perfect power of a prime, and it will again get. So what I'm trying to say is, whenever n1 is less than or equal to 25, we can force, n2 will force something so n2 can get eventually a number strictly less than the square root of n1, which is less than or equal to 5, right? Do you guys agree that? So therefore in the next step n2 will be at most 4 or even lower, and so therefore n4 in the following step will be less than n3, the square root of n3, and so on. So we will get smaller and smaller numbers, and eventually B wins, right? So in this case, and B wins. So that's really nice. And finally, I hope that was clear, but it's kind of okay. So finally, what happens if n0 is equal to 6 or 7? Well, when it is 6 or 7, A will have to pick one of these two numbers, 30 or n1 will pick, or it will have to pick 42. Why does it do that? Because following the trap that n1 faced in the first step, namely the trap was that at most any number less than 25 would have at most 2 prime divisors, not 3. But luckily 30 has 3 prime divisors, and the same thing with 42, which have 3 prime divisors. So what this allows n1 is we can go to 30 or 42. In that case, let's focus on 30 for instance. In that case, n2 picks, B picks, okay, let's write it properly. Okay, so if A picks these numbers, then B picks, let's start with 30. So if n1, let's assume that n1 is 30, then B picks, smallest that it can pick would be 30 over 5, which is 6. Okay, we go back to the original situation. The largest that we can pick would be 30 over 2, which is 15. Obviously, B will never do that because B knows that anytime we pick something greater than or equal to 8, A wins, right? So we have investigated that. So what happened was that so B will pick again 6, right? 6 or 7 actually. And then it will be an infinite loop because A will pick again 30 and no one will win in that case. The same thing will happen with 42 because the smallest that B can get would be 42 over 7, which is 6. The largest, obviously, 21, but B will never pick this one. B will pick 6, A will pick 42 again, and then again an infinite loop, so no one wins. So therefore, the final result, conclusion, okay, so we get that, so for part A of the problem, A wins if n0 is greater than or equal to 8, basically. And part B, B wins if n0 is, it's given that n0 is strictly greater than 1, obviously, 5. And finally C, no one wins, no winner, or no winning strategy, I should say, if n0 is equal to 6 or 7. And that solves the problem. Hope to see you guys in our next video.